Hello everyone. In this video we're doing activity 5.3 in Jamovi. So for this activity you actually have a really small data set with only 12 people. And in this data set people were asked to rate their driving ability on a scale from 1 to 7, where 1 was below average, 7 was above average, and 4 was average. Okay. And what we want to know is, do people think that they're better drivers than they really are? If we take a random sample of people, we would expect the average to be 4, since that is the midpoint, the average on the scale. Okay. So we're going to do a single sample t-test. Click on t-test and do a one sample t-test. And driving confidence is our dependent variable. We're going to move that into the dependent variable box. Now, the point of this analysis is to compare the mean driving confidence score for people to the midpoint of the scale. And the midpoint of the scale was 4. So I'm changing the test value from 0 to 4. Okay, otherwise, it's just going to compare our mean to 0. And 0 doesn't make any sense because it's not even a possibility on the scale. Right? The scale ranges from 1 to 7. Okay. All right, so we changed that to 4, and then we're going to look for the mean difference in the confidence interval around the mean difference. We're also going to get the effect size and the confidence interval around that. Get descriptive statistics and descriptive plots. Okay. I've left the hypothesis as the default. It's a two-tailed test because that's what we're doing in this case. Okay. All right, so here is our output here. We have a mean confidence rating of 4.58 with a median of 4.5. Standard deviation is 1.16, which is the typical distance scores are from that mean of 4.58. And our standard error of the mean is 0.33. That's the typical distance we would expect between sample means and the population mean. Okay. So our t is 1.73. with 11 degrees of freedom, and our p is 0.11. The mean difference is 0.58. Now, first of all, we have a 95% confidence interval around the mean difference. So we could be 95% sure that the true mean difference is somewhere between negative 0.16 and 1.32, which is a big spread. Okay? And that's a really big spread because we have a really small data set here. Okay, next we're looking at the Cohen's d. This is our standardized effect size, where we get a standardized effect size of 0.5, which is a medium size effect using our standard guidelines. But our 95% confidence interval is somewhere between negative 0.11, which would be a small in the opposite direction, to an upper limit of 1.09, which would be a large in the other direction. Right? This is a really wide set of confidence intervals. Again, this is coming from this very small sample size. Right? So in this case, our p-value is 0.11, and we usually use the guidelines of around 0.05. People think that tends to be sort of a real difference, sort of strong evidence against the null hypothesis. 0.11 is weak evidence. But it does suggest that we would probably want to pursue this line of reasoning a little bit more. We have a moderate size effect. Our p-value is lowish, but we just have a really small sample size. So at this point, we can't really draw any firm conclusions at all about this. Like, there might be something there might not. We just need to look into this in some more detail. Okay? And that is all you need to do this activity.